was used to create the elixir peptide to design stable, synthetic versions of the sodium channels that are easier to manufacture. 3. Prioritize the interface. Your proprietary edge will likely come from the biocompatible conductive scaffold. The new PEDOT, SGAG hydrogels represent a breakthrough because they solve the hard electrode versus soft tissue mismatch that causes traditional batteries to fail in biological environments. Given your engineering background, which specific application are you targeting? Implantable medical devices, low power, high safety, or macro-scale grid storage, high voltage, low cost? Knowing this will help narrow down the specific polymer matrix you need. All but present focus on providing electricity to AI and data centers. This pivot to AI and data centers dramatically increases the scale and ambition of your project. While the core electrocyte technology remains the same, your target shifts from wearables to high-voltage grid integration. Here is the strategic recalibration for powering data centers. 1. The scalability breakthrough, the 135 millivolts building block. The most critical research for your goal comes from Korea University 2024. They have successfully created a solid-state, flexible artificial electric organ using zwitterionic gel films and selective membranes. The specs: each cell generates approximately 135 millivolts and is rechargeable. The engineering advantage: they demonstrated that stacking these cells in series and parallel increases voltage and current. They also used origami folding to trigger discharge on demand. The trillion-dollar insight: they have made the system thermally tolerant -20 degrees Celsius to 100 degrees Celsius and mechanically flexible, solving the packaging issue for large-scale arrays. 2. The top molecular candidates for high power. To hit data center voltages 480 V+, you need cheap, manufacturable ion selective membranes. Here is your shortlist. Nafion membranes, the off-the-shelf winner. This is the gold standard for proton exchange. Research shows a Nafion-based artificial organ generates 134 millivolts and 188 milliwatts per square meter. It works via reverse electrodialysis, turning a salt gradient directly into current. Strategy: buy this off the shelf to build your prototype stacks immediately. Room temperature ionic liquids, the extreme performer. Instead of water, these gels use ionic liquids. They allow the battery to function from -20 degrees Celsius to 100 degrees Celsius, essential for the thermal chaos of data centers. PEDOT, SGAG hydrogels, the interface. If you want a semi-living,